Crypto 101. Learn more at bitcoinblockchaincrypto.com. You've probably heard of Bitcoin and cryptocurrency. But to really appreciate the value of this new technology, you have to understand the world before blockchain technology. Before blockchain technology, doing transactions around the world required basically central institutions like banks and other financial institutions that had to put in huge investments to create the infrastructure to do those transactions. Because there's only so many of these institutions, because of the cost to start one, transaction fees were quite high. In order to do business with these institutions, you have to give up your personal information. So doing transactions around the world were very limited in privacy. Enter the blockchain. A blockchain is a distributed ledger, meaning it's an account of several transactions, but it's not held in any one particular place, not one bank, one financial institution. It's spread across among many people who voluntarily decide to hold on to this ledger themselves. Now, these people who keep a copy of the ledger can also verify transactions, maintaining the integrity of the ledger. But why would someone voluntarily maintain a copy of this ledger and verify transactions? What is the incentive? This is where Bitcoin, or whatever cryptocurrency is of that particular blockchain, comes into play. It's the reward for people maintaining the ledger, verifying transactions by creating blocks on the blockchain. Think of a block as a page of transactions on the blockchain. And when you create one, you get rewarded in cryptocurrency for doing so. The benefits of blockchain. Decentralization. Since no one institution or actor holds the ledger or verifies transactions, it ensures that the network will perpetually be up and exist for people to transact on. Most blockchains offer you the ability to transact anywhere with anyone at very low cost compared to traditional financial institutions and networks. Transacting on the blockchain doesn't require you to deal with any particular financial institution. So in that case, it doesn't require you to give up any particular private information unless you choose to, in order for the conveniences of using financial institutions. Use case examples. Cyprus once threatened that they would actually confiscate a portion of all their citizens' bank holdings, so everyone rushed to buy Bitcoin, which allowed them to operate financially in a network where the government couldn't just confiscate their wealth. Venezuela's communist regime kept printing so much money that the value of their local currency kept falling down. So Bitcoin allowed the people of Venezuela to be able to generate an income and be able to transact financially in something that had much more stable value than anything else they could access. That was basically easy enough to hide so that way they wouldn't get arrested. In Africa, Bitcoin has become a major medium of exchange when it comes to currency exchange and remittances between African countries. The company BitPesa, by using Bitcoin as an intermediary, has actually made it possible for countries that typically had a hard time having money exchange, remittance type companies to be able to do so, and enabled these kinds of companies to be able to operate in more places more robustly all across Africa. Bitcoin's challenges as it grows in popularity. Now that Bitcoin is doing more transactions on a daily basis than it ever has before, it's taking longer for transactions to be confirmed. The Bitcoin price rises. What used to be fairly low and insignificant fees have now become quite large. Other blockchains have introduced the ability to use cryptocurrency for non-monetary purposes, such as token issuances, smart contracts, and decentralized applications, which Bitcoin currently does not support. Solutions that'll help Bitcoin overcome these challenges. Segwit, or segregated witness, basically creates special Bitcoin addresses that make it easier and quicker for confirmations to occur. Lightning Network is a settlement layer that is soon to be released that allow blockchains, not just Bitcoin, to basically settle transactions in a batch. So instead of putting every individual transaction on the blockchain, it'll allow all the transactions to be batched at the end of the day by different nodes and financial institutions to create one massive transaction at the end of the day, lowering fees and increasing speed of transactions. The Omni layer is an existing technology that allows you to do token issuances on top of the Bitcoin blockchain. RSK is another technology being built upon Bitcoin that allow you to do also smart contracts and decentralized applications on top of the Bitcoin protocol. What are tokens, smart contracts, and Dapps? Tokens are just basically another currency built on top of an existing blockchain. You can create tokens in order to use them as money, to use them as like shares in a company or as prepayment for a service. You can create tokens for any purpose, and some blockchains allow you to do so. Smart contracts are just self-executing contracts. The terms of the contract are programmed into basically onto the ledger of the blockchain, and then will self-execute when certain events happen. So this allows people to enter the same kind of contracts they would in real life without having to worry about who keeps track of the enforcement of the contract. Dapps, or decentralized applications, are actually full-on software suites built on top of a blockchain that don't run through any particular computer or are run by any particular company. They're software that's built, exists on the blockchain, and can always be used regardless of what's going on in the world. So essentially creating ways of providing services and goods in a way that kind of runs itself. Now, the blockchain that really made the whole idea of token issuing, smart contracts, and Dapps popular was the Ethereum blockchain, which still exists today and is quite popular. Other blockchains that support token issuances, Dapps, and smart contracts include Ethereum Classic, EOS, Expanse, Waves, NXT, Ardor, and BitShares, and many, many, many more. What is mining and forging? So remember, there's people who voluntarily keep their computers on so that way they can verify transactions and maintain the blockchain. But there are different mechanisms for how we decide which of them to reward and when to reward them, and here's a few of them. There's proof of work, which is used on blockchains such as Bitcoin and Litecoin. In this situation, you set up your computer to guess basically a number, to crack a code, kind of like opening up a treasure chest. Whoever cracks that code first wins the Bitcoins and creates the new block, referred to as mining. Now, the amount of guesses you can make per second is referred to as your hashing power. So the more hashes, the more guesses you can make, thus the more likely you'll unlock the next block. One of the issues with proof of work is that it uses a lot of electricity and is not very environmentally friendly. So a lot of people have started using proof of stake, where the likeliness of you unlocking the next block is based on how much of the currency you hold. So the more currency you hold, the more likely you'll win the next block. And on top of that, other people on the network can lease or delegate their currency to you to increase your staking power when you forge. There are other methods that people use, ones that measure how much hard drive space you have and reward you for that. Other people reward you for how often you transact, and many other possible alternatives on different blockchains. Other challenges for blockchain. Things like Segwit and Lightning Network will solve a lot of the transaction fees and transaction time problem. At the end of the day, that blockchain, that list of all the transactions gets bigger every day, where it can sometimes be several hundred gigabytes for every computer that wants to hold the blockchain. So how do we keep track of all this information and maintain it as it starts becoming terabytes and terabytes in size? The Lambda project and the Komodo platform are both trying to create solutions to this problem by creating the ability to create interoperable blockchains. So that way it becomes a network of networks. So that way one computer doesn't necessarily have to hold everything that's ever happened, but it can set and hold a particular blockchain for a particular use and get particular rewards, yet all these different networks could work together to create a massive network. Privacy. The Bitcoin blockchain is an openly available ledger. So with enough effort, people can figure out, where different transactions come from and figure out who people are. And most people still use intermediaries even when doing transactions on the blockchain because it's more convenient. So this limits your privacy. So people are trying to develop alternatives that protect your privacy even more. Among the different blockchains that are trying to solve the privacy problem, they include Monero, Dash, Zcash, Zclassic, Eon, and Stealthcoin, and many, many more. Please visit my website, bitcoinblockchaincrypto.com, to learn more. Subscribe to my podcast, the Bitcoin Blockchain Crypto Podcast, on iTunes, Google Play, and Stitcher. If you enjoyed this video and want to support my ability to make more and continue educating people, please make a donation at donate.alexmerced.com.